lesson has to do with transformations, which has to do with taking a basic graph and maybe stretching it out. If you can just imagine, you know, if you had a graph picture on some silly putty, if you could stretch it one way or another or move it back and forth. And so what we're going to do is take one thing and change it into something else. And that topic is called transformations. So these are the things that we will typically take to transfer to something else. Now, this is not every single parent function, but a parent function is, in my explanation, the simplest function of its kind. You're not going to have any numbers in it for coefficients other than a 1. And you don't have anything added or subtracted. Now, you could have powers that are not 1, so you can see here things that are squared. But then our most basic functions then, no coefficients other than 1, nothing added or subtracted, and they have some real commonalities. They go through the point 1, 1, all of them. If possible, they go through the point 0, 0. Now, why wouldn't they? Because maybe 0 isn't in the domain. Like 1 over x, 1 over 0 is undefined, and you can see there's no point 0, 0 there. But almost all of them contain the point 0, 0 and negative 1, negative 1. The ones that don't contain the point negative 1, negative 1 are those that actually won't allow this negative for one reason or another. So you can see that if I plugged in a negative 1 to x squared, it would just simply make it positive again. The square root of negative 1 is not a real number that we can graph on a real number system. And then if I plug a negative 1 into the absolute value, it becomes positive again. But all of them do contain the point 1, 1. Okay? So those are parent functions. These are not all of the parent functions, but it's a good number of them. Now, if you want to look at a page that you could print out with functions on it, you can go into your MML homework and test where you normally do your homework, but choose the Mastering Course Home, or My Lab and Mastering Course Home. Then click on Additional Resources, and I think it's the last one that comes up, but we have a library function. Now, not all of those functions that are on that page are parent functions, but it does include those parent functions I just told you. So you just have to keep in mind if they've got numbers that are added or subtracted or coefficients besides 1, then they don't apply to parent functions. So we're not going to spend a great deal of time on here. If we were having an in-person class, I would have somebody play with all of these numbers. So on this calculator, just so you can see something, if I put in, and I'm not going to put in all the values at once, but if I put in an x squared, that's a parent function. And then let's pretend for this parent function that a is 1, c is 1, d is 0. So I've just got x squared. But then I can play with what this b number is, okay? So if I put, right now, just like it is, this is what it looks like. If I go back and I say, okay, well, let b be 2. So if I put plus 2 out here at the end. Oh, well, it was here, but now it's here. Again, I'm going to put, let's put in minus 5 and see what happens. Okay, so now you can tell that that last number moves things up and down. All right. So now I'm going to get rid of that last number. I'm not going to play with all the values here. I'm going to let you trust me on some of them or play with it on your own. But we do want you to see a couple more things. What if I stick a number in front of the whole thing? So let me stick maybe a 3 right here in front of it. Okay, that's the one with the 3. So that we can really compare, I think I will do a second graph and maybe put a 1/2 in front. So what if I have 1/2? this one with the 1/2 is going to graph in red. Okay, so a 3 makes it look more narrow than the 1/2. So we can see what that number in front does, and it affects the way things look. And so I'm not, as I said before, we're not going to spend a great deal of time playing with all of these. We would do more if we were in an in-person class. You can do that some on your graphing calculator. I would encourage it because I think you understand it better after you see it. But for the sake of time, we're going to move on. So this is an important slide. It's one that you may want to take a screenshot of or snap a picture of. It's got a great deal of information on it that we'll be referring to during this lesson. And it tells us essentially what each one of the numbers does. So let's look at A. The absolute value of A is what you want to consider to see if it's a vertical stretch or compression. And if the absolute value of A is bigger than 1, it's a vertical stretch. If the absolute value of A is less than 1, it's a vertical compression. And you will have to know what that factor is, like what the multiple is, and it is the absolute value of A. So if I have a -3 out here, then I would still say that the factor was 3, because the absolute value of A would be 3. And since the absolute value of A is 3 and that's bigger than 1, I would say it were a vertical stretch by a factor of 3. Now what does a negative do then? If A is negative, what it does is it reflects it over the x-axis. Okay? A is negative, it reflects it over the x-axis, so it's just going to flip it down. So if I go back here and I insert a negative there, what you can see is that that one is now headed down. Okay? C is also a stretch or compression, but C is multiplied to X, which means C affects horizontal movements. Now, everything that's in this group with the X is a little bit deceptive. So I often say if it's with the X, you can't trust it. After all, this is why the X is the X, right? You wouldn't have broken up if they were trustworthy. And that's just kind of a little way to help you remember what's going on. So C is with the X, which means when the absolute value of C is greater than 1, typically we would think it's getting bigger, but that actually is a horizontal compression. Don't trust it if it's with the X. It's a stretch when that absolute value is less than 1. And instead of it being a factor of C, it's a factor of 1 over C. And that should really have absolute value around it. It's the absolute value, but it's going to be with a 1 over. What the negative does is a reflection over the y-axis. Okay, D is the next value we come to, and D is again grouped with the X. Since D is with the X, it's a horizontal movement. But again, don't trust it. If it has a negative, it is actually moving things to the right. And if we have a positive here, it is moving things to the left. Okay, so D is a horizontal movement, but watch the sign, it's lying. Any power that you see here would help you reveal the parent function. You know, it could just be an x squared or an x cubed. So anything that if you have some other grouping symbol like absolute value, you know, you're going to find those in there. That's going to be your parent function. Now, B is a vertical movement. It's not grouped with the X, so it's not lying to me. It's telling the truth. Okay? So we're going to apply all these on the next screen. Well, excuse me, the one after this. There we go. So sometimes instead of giving us that particular function, they're going to just say f of x, but whatever we're sort of grouping we have, watch for grouping because that essentially gives it away. So whatever that grouping is just your f of x. Okay? Now for the practice of it. First of all, let's look at what are the parent functions, because the parent functions, we're going to look at other numbers besides those to determine what our transformations are. So parent functions cannot include any addition or subtraction. They don't have any negatives. It's just that most basic one. So right here, that's my parent function. And I know I'm just kind of doing this, but just take some practice. We don't want any of the extra numbers. Don't want the negative that's in front of the thing, so I've got an X on this fourth one, but it is cubed. That's what that pound sign on the previous, or a couple of slides back, was referring to. Here I have X and squared. X cubed, and then this one will be the square root of X. So in all of those then, the parent function I have highlighted in yellow for you to see. So now what we want to do is look at all the rest of the numbers and figure out what is happening. What do they refer to based on those compressions and stretches and slides? And so I'll talk it through exactly. I may save myself a little bit of writing and have some abbreviations on here, but this is out. It's not in any sort of a grouping symbol, so we call it outside. It's with the Y values, so it's not lying. So this one is moving it up 4. In the same way, I can see that this one is getting moved up 3 units. But what does this negative here do? Well, the negative is a reflection, and that is a reflection over, now since it's, boy, you can't hardly read that, but since it's not in a grouping symbol, it's actually affecting the Y values, and so to reflect in a way that reflects the Y values, it's reflecting it over the X axis. That's what the negative does. Now the 3, on the other hand, because if we take the absolute value, we have a 3, that is a vertical stretch, and it's a factor of 3. This 1/2 is not grouped in there with the X, so again, it's a vertical stretch or compression, but since it's 1/2, that one is a vertical compression. The factor is 1/2, and this -2 has moved it down 2 units. Okay, we're going to do one more, and then I'm going to bring up my calculator to show you how this is actually happening. But what we see here is this negative. The negative is a reflection over the x-axis. The -2 is grouped inside with the x, so it's lying to me. So instead of going to the, it is going an x direction because it's with the x, but this one is actually going, and I said it's lying, and I almost didn't write it down, but this one is actually going to the right 2 units. Maybe I'll just draw the arrow. So let's just pause for a minute and compare the parent function x cubed to what we have here. So I'm going to go back to y equals, and we're going to clear these. So my parent function on that one is x cubed. And then this transformation has a negative parentheses x minus 2 close parentheses cubed. Okay, so I've got the parent, which will show up in blue, and then the red one will show me the transformation. Okay, so what we see is that it was going up on the right and down on the left, but now that is reversed. That's my reflection. And then this little point of pivot here, point of inflection, was at 0, 0, but now it has moved 2 over to the right. So it has gone to the right too. So I can verify that and see it. Sometimes though, you don't want to just use your calculator. Sometimes you can just start with your calculator, and I understand that. But sometimes that calculator, you can see it's going to get a little bit iffy to tell what's going on. You have to, like, even I look at it and think, I don't know why it did a nice job of connecting it on the first one, and then it didn't connect it on the second one. Calculators just have some limitations along the way. Okay, so now let's look at this next one. We see the parent function is x squared. This is inside with the x, so it's lying. Anything added or subtracted is always just a slide, though. So this is sliding it to the left 1 unit. This one is sliding it down 1 unit. It's not lying to me. Numbers that are multiplied are either stretches or compressions. Since this one is not grouped with the x, it's vertical. The vertical ones don't lie, so since it's smaller, it's a vertical compression. And then that factor is 1/3. The +2 means it has gone up 2 units. And on our last one here, this one's with the X's, so it's lying. It's an addition or subtraction. Any addition or subtraction is a slide, up, down, left, right. Since it's with the X, it is sliding it left or right. It is lying, line X, so it is moving it actually to the left 2 units. So those are the transformations. The more you understand this, then the more you can tell what the graph looks like before you actually go through the tedious details of plugging in numbers and graphing things. So all of these graphs kind of have that V shape, although some are V's up and some are V's down. And that's because all of these graphs actually have the same parent function. And the parent function is y equals the absolute value of x. Okay, so they all have that same basic shape, but then some have been moved right or left, up or down. And we don't have to do these in any particular order, but a lot of times on your homework you're going to have to choose the right graph. So this is some practice for us. Let's just let's do any of them that have addition or subtraction at the end first, because addition or subtraction at the end indicates that it's been moved up or down. Okay, so this one should have that vertex, that point, up 1 unit. B is up 1 unit. Now it's also moved over, but does that verify? This one does indicate that it has been moved to the right 1 unit. So it was moved to the right 1 and up 1. So that one is B. Okay, but using slides at the beginning is usually the easiest thing to do, and then we will do any compressions and stretches later. So this one's been used. So let's go to the next one that has addition or subtraction. And here's this one. It's in there with the X though, so I know it's lying to me. So this one actually should be moved over to the left 2 units. That's the only addition or subtraction. So something that's been slid to the left 2 units. And it's right here at G. Okay, so G has to be this one. Okay, I'm just doing the easiest ones first. Anything with addition or subtraction will be easiest. So now this one has been moved up 3 units. So I'm looking for something where the V has been moved up 3 units. And this is the only one where that one applies. So that one must be D. Now this one has been moved to the right 4 units. Okay, so to the right 4 units. Appears to be this one, H, but I notice it's also headed down. But if you look over here, that negative in front means it's opening down. So that actually works just fine for me. So that one's H. This one has been moved down 3. I know there's something different about the shape because of the 1/2, but focus on the easy parts. It's been moved down 3. So down 3 is right here at I. That's the only one we have that's been moved down 3. Okay, so that one's I. Number 9, we have a down 2. Okay, that seems to go with F. I do notice that this one is going down, so I can verify. This negative in front means it's going to open down because it reflected across the x-axis. So it's going down, and the vertex was moved down 2. So that one is F. Now, in that way, we have eliminated a lot, and we can see what else is going on because out of the ones, I already did I. So out of the ones that remain, we have A, C, and E. All right, now none of those have been shifted. They've all got that vertex at 0, 0. But notice only one of those is opening up. So it has to be an equation that starts with a positive number, which means E cannot go with number 1 or with number 3. So it has to go with number 4 because it's opening up. This 2 in here actually means it was a horizontal compression of 2. So when it goes over 1, instead of going through the point 1, 1, it only goes half that far. Okay, horizontal compression of 1/2. actually, because it's the insider lies. The thing with the X lies to us. So now we have 2 to choose from. And if you get stuck, you can just plug in a number or check your calculator. But again, using this approach is generally faster than typing all this into the calculator. They both open down. And if all else fails, just pick a number and plug it in. But this one is a vertical, because this 2 is on the outside. So this is a vertical stretch. Okay? If somebody stretched you vertically, it'd be like making you taller and pulling things out. So out of these 2, which one then is looking taller? It is the C, even though it's going down. That certainly has a steeper effect to it. And this is C. Now, if you need to, you could say, well, if I plug in the number 1, the absolute value of that is 1 times -2 is -2. So you can just say, if I plug in a 1, I get -2. And here is 1, -2. Okay? So obviously, this one must be A. But again, that is because this is a horizontal stretch. Remember, the things with horizontal lies to us. So it's gotten wider. All right? If you plug in a 1 here, then that's a 1/3. And with the negative in front, we would get -1/3. 1, -1/3. Oh, barely down at all. So you can see that. So certainly, again, you can use your graphing calculator, but it may be faster just to recognize some things about the slides and transformations. One of the things you'll have to do in your homework is you write the equation. So when you write the equation, they're going to give you the parent function and tell you how to do some transformations to it. If you could write it down on scratch paper, one of the handy things to do is just leave yourself space in case you need to go plug in some numbers. So this looks like I've lost my mind because I've left space for where I might put the A or C, D or B. We've got just space there. I'm going to do that for each of these. So y equals, and I'm going to leave some space, absolute value of x. And then y equals square root with an x there. So those are my parent functions. I just got this extra spacing on them. Because now I want to go back and write in the extra transformations. Now, reflected across the x-axis means that I need a negative in front. Shifted to the right 3 units. If it moves to the right, it goes in there with the x, and the insiders, the things with the x, lie to me. So I should not put this because this is what we think would happen if we moved it to the right. But the insiders lie. So that actually ends up being a negative. And then we have up 4 units, and the things on the outside don't lie. All right, on our next one, we have a horizontal stretch. If it's a horizontal stretch or compression, it's going to go right here in front of the x. But the factor is lying to us. So even though it says a factor of 2, that number is a 1/2. Okay? Shifted down 5 units. That one doesn't lie. It goes on the outside. Now this next one is tricky because of what it has happening. But this one is to the left 2 unit. Whenever you have, and I am going to back up to one of our slides. Hang on just a minute. Whenever you have both a C and a D, those can be really tricky because most of the time you will only have a C or a D. But if you have a C and a D, you actually have to factor it out first. Okay, there's no great way for me to say that, but if you have both a C and a D, you need to factor the C out first. So let's go back and look at this one. What happens here is that because this is reflected across the axis, and it's reflected across the y-axis, that would indicate to me that C is -1. And it's shifted to the left 2 units. Okay? However, I need to factor this -1 out. Now I'm going to write down what the answer is and then try to explain it, because it's just, this one is just tougher to see. So if I put my -1 here, now normally a left 2 units would mean that I wanted to add 2. Okay? So it's this negative that's in front of the whole thing that changes it. And you can see it written here with parentheses, but they typically are not going to have you write that. So I wish I could help you out. It only occurs when there's both a C and a D. But what you will want to do is take the C, if you look at the way it's originally written, matches the information given, -1, and then open parentheses. Then I did my X plus 2. So that matches the way the information was given, but when you distribute it, that sign changes and it looks different. Well, what if you don't have the equation and you're still supposed to do this sort of thing? This is when you really want to consider, what does the transformation mean? So this -2 that's in front, we know that this is a reflection, and it's going to be over the x-axis. So what was up will end up being down. And then the 2 part means it's a vertical stretch with a factor of 2, which really means it will be twice as far vertically. So I can take this point, -40, and say, well, when I flip it over, I'm still at -40. And when I stretch 0 out, it stays at 0. This point, -3, -2, will actually flip over and become -3, 2, but then because of the vertical stretch, it has to go twice as far, and it moves to -3, 4. So yes, when you have something multiplied to f of x, since f of x is a y value, you can just multiply it to the y value and that will work. But you're going to have to be more careful when something's grouped in there with the x. So here again, when I flip this over, it becomes -1, 2, multiply it vertically by a factor of 2, and I end up at -1, 4. The 0 point doesn't move when we flip it over or multiply it. The point 2, 3, though, reflects to 2, -3, and then it gets stretched out to 2, -6. The point 5, 0 doesn't move. So if I can connect these, and we know it'll be a little bit crooked and shaky with this app thing I'm using, this pad. What we can see is that it is reflected over x, and it is stretched vertically. It's now twice as tall as it used to be. In a similar way, if you want to make it smaller, because this is an f of x and that's a y value, you can just take half of the y value. So that'll go a little bit faster. We do have to be more careful when it's with the x. So half of 0, I'm just taking half the y values. And then I get to -3, -2. Well, half of that's -1. -1, -2 becomes -1, -1. 0 doesn't move. 2, 3 becomes 2, 1.5. And 5, 0 stays the same. So when we have the 1/2 in front, what that was a vertical compression, and the factor, the factor is 1/2. Factor is 1/2. It is now half as stretched out vertically as it used to be, half of that vertical distance. We're going to do this again with the x's, and again, I can't say it enough, you've got to be more careful when we've got it with the x, because you've got to think about what this means, okay? The negative would be different if we had the equation, but here we don't have the equation. What that negative means is that it's a reflection over the y-axis, and then this 1/2 part means that this is a horizontal stretch, and it's a factor of 2. So it's going to get twice as wide. Remember, the things with the X are lying. So if this one is horizontally out 4 units, it's going to come out 8 units. The fact that I have a negative in front is going to move it the other direction. I'm just going to kind of have, that's going to go off my graph, but 6, 7, 8, it's going to essentially be right here. So I'm looking at the X's, the negative is going to change it, but then the fact that it's a factor of 2, and you can't see that, you're going to have to know that. I can multiply by 2. So it's going to become, this negative 3 will become positive 3, then times 2 is 6. So I have the point 6, negative 2. All right. This point will become 1 times 2, which is 2, negative 2. The 0 doesn't move. This becomes negative 4 because it's going to flip to the other side and have a factor of 2. So negative 4, 3. And then this one is going to go off my graph, but this one would be at negative 10, 0. And I'm just going to kind of have to pretend it's somewhere over there. It's not really going to be on the slide there. But if I could do that, then and what you can see then is that definitely is a horizontal stretch. I can't draw straight lines on this thing, but it's a horizontal stretch. It's now twice as wide. Okay. What the 1/2 kind of means is it only gets half of the stuff done in the same distance, so you have to go twice as far to complete it. And again, then over here on this next side, this last one, this one then does not reflect, but it is a horizontal compression, and then the factor is 1/2. So you're only going to go half as far over for the same height. Okay? The 2 means you would have to go, well, you got to put half in there to get the same height. That's probably, I don't want to explain it too many different ways. So instead of negative 4, 0, we've got negative 2, 0. I've got negative 1.5, negative 2, negative 1/2, negative 2, 0, 0, 1, 3, and 2.5, 0. So you cannot get that from the equation. You have to stop and think, what does that number mean? And then how do I apply that? Okay, since I know it's a horizontal compression and the factor is 1/2, then you can do 1/2 times the X value. If it's a horizontal stretch with a factor of 2, you can do 2 times the X value. And then just stop and look at it afterwards and think, did this horizontally stretch it? Yes, it did. Did the next one horizontally compress it? Yes, it did. You want to make sure it does what you know it said it was going to. Let's look at this one just briefly. This one is one exactly like I was just working. You don't particularly have to watch their video if you've watched mine. You've just got to think, okay, it's going to flip it over. This one's going to flip it over the x-axis. And then this is a vertical stretch of 5, so it should get a lot taller. So instead of going down first, though, that means it's got to go up first, but it's going to go 5 times taller. Okay? So you just got to think of those things and apply that because they're not giving you an equation. So I would need to choose like option D if I were going to do that. I get a lot of student questions about this one. And I'm not necessarily going to work it all the way through, but here's what's going to happen. On this drop down, you have a choice of a lot of different things. You need to deal with any stretches or compressions first. Stretches or compressions first. Now, one of the things I'm going to say is that if you're doing this, you have to very first of all figure out, well, what is that remotely like? Okay. What I know is that that said that my parent function was 1 over x. It's kind of off the screen for you now, but that was the parent function. But now I have 2 over negative 3 x minus 3 minus 2. What I want to do first of all is figure out what do I have to do to this to turn it into that. Okay? Well, first of all, let me highlight. We've got this 2, all of these extra numbers. Now, since I have a couple of things here, this is kind of strange. I've got to get a 1 up there to see what they've actually multiplied by. So I'm going to factor this 2 and the 3's out. And this is just, it takes some practice to get used to this. And you may have a different one on your homework that I'm looking at right now. But if I factor negative, or I want to say negative 2/3, but I'm going to put that negative 3 on the bottom first of all, just so you can see it. If I put a 1 there, and then I put x plus 1, and then let me still hit minus 2. If you notice then, I took the 2 from the top and factored it to the front, so I just have a 1. And then I took this negative 3, it's not so much because it was second, it's because it was right in front of x, and I put that, factored it to the front. So now I can see what they've multiplied by in both cases. It doesn't have to be written separately. This is also the same as 2 times 1 over negative 3 x plus 1 minus 2. It kind of just depends on how you need to see it. My point here is that 2 is not grouped with the x, but the negative 3 is. Let's talk about what those things do now. This is where I had both a C and a D, so I factored it out. So this one is my horizontal, and it's a horizontal compression with a factor of 1/3, because don't forget you got to turn those over. And that one is also a move then to the left of 1. And again, if you look at it in the original form, that looks like it's going to the right, but that's both of those numbers with the x are there, so you need to factor it first. That's going to move it to the left 1. Now, what does that negative do? Whether or not you stick the negative in front of the whole thing or anything else, that's going to be a reflection. Because they do have it on the denominator with the x, then I'm going to say that that is a reflection over the y. I know you can't really read that over y. This minus 2 at the end is down 2. And this 2 that's in front is the vertical stretch. And the factor there, I'm just going to say of, but the factor is 2. So I have 4 different things. Now, when I go to enter that on the homework, though, you need to deal with stretches and compressions first. Stretches. So I've got a vertical stretch of 2 and a horizontal compression with 1/3. Vertical stretch or compress by 2. Now, I wish personally that you didn't have to transform it in the middle, but you do have to click transform. However, don't start over. I've already got all my information written down over there in blue. So it was a vertical stretch of 2, and then it is a horizontal stretch with 1/3. Okay, then after you've taken care of those 2 things, I want to do with my other stuff. So besides that, I have a reflection over the y-axis, and I have to move it to the left 1 and down 2. Reflection over the y-axis, to the left 1, and down 2. If you look at all the intermediate things, it's going to be too confusing. So do all of them at once. And then if you want to check it yourself before you click check answer, that's when you want to bring up your graphing calculator and type it into your graphing calculator and make sure that what you have matches. But don't look at all those little intermediate transforms. It's just going to be too confusing for you. Okay? So I hope that's helpful. Do send me questions if you have screenshots. Show me pictures of your work, whatever you need if you have questions. But that finishes up today's lesson.